Okay, so do you see the screen again? Okay. So we were talking about uh, how to do the analysis of the value of the return on investment we get. So higher is the return of investment, better is my project, because this will give me a larger intervals of future confidence in future for which my project will be profitable. And then we said that in order to take into account all the risks that we have when we are doing the project, we calculate what is called the CER, which is the capital enrichment rate, which is calculated as the net present value at year end over the investment. And we say that this CER should be larger than 0.3. So at least we should gain 30% of our initial investment. This means that if I invest, let's say, with $10,000, okay, then at the end of my lifetime, I should gain $3,000. Okay, so in this case, I can consider that it is considered as a profitable project. So let us now go with the details of calculation, how we can determine the rate of return on investment, ROI. To calculate the value of the ROI, I should apply just the formula. So I should set that the net present value at year end, which is the balance between incomes and costs over the whole lifetime of the equipment, should be equal to 0. And when I do this, the only unknown in this equation will be A. So ROI represents the value of A, which will give me a net present value just equal to 0. So let us together find all terms in my equation. So first, I need to know the investment. We have seen together that for this problem, the investment can be calculated as 2,000 times 3, because this is the price of my wind turbine. So it's 6,000 euros. So in this case, my investment is equal to 6,000 euros. So this is for I. Now, concerning the calculation of this term, okay, I have to determine the incomes and costs. Concerning the incomes, I don't have a constant income through years, and this will be a little bit challenging concerning the calculation of this term. Okay, and we will see how to do it. So first, they told us that for the first year, the selling price will be 0.13 euros per kilowatt hour, and after the second year it will be reduced a little bit, and at the end it will stabilize. After 3 years it will become 0.1 euros per kilowatt hour. So we can conclude here that for year 1, 2, 3, the selling price, which is the income, will be higher than from year 4 to year 20. And in general, such projects are done by countries, and the state can force, they can force people to use this technique. This is why when you want to set a project, especially a renewable energy project, you should have a strong state that is able to impose on people to use this renewable energy, because in general, using fossil fuel energy at the just at a certain term will be beneficial on the economical level, because it will cost first a lower amount than renewable energy, because as you know, you should compensate your investment. So you should, for first years, you should have a high selling price. And this is why you need states that encourage the use of renewable energy by imposing on people to use it. And this is what was done in developed countries. And then after, at a certain stage, when their project becomes with a certain benefit, you have a certain balance, they can reduce the price. This is why after year 4 they can sell at a lower price of 0.1 euros per kilowatt hour. Okay, now Because we have different costs here, we should take this into consideration into the calculation of this summation. Okay? If you remember last time when we talked about this summation, we said that we can use a mathematical formula for its calculation. But what was the condition? The condition was that this term is constant. So because this term is not constant over years, we will play a little bit with the formula together to see how to calculate it. And we'll see this in details now. Just before, let us determine the cost for year 1, 2, 3, and the income for year 1, 2, 3. Concerning the cost, it is a constant cost because they said the yearly maintenance is equal to 2% of the capital cost. The capital cost, which is the investment, is 6,000. And since the maintenance cost is 2%, so I just have to multiply by 2 over 100. So I get it's equal to 120 euros per year. So we can say that the cost is constant. So this is C over any year. This is CI. At any year, I should pay 120 euros as cost. Now, concerning the income is variable. For year 1, okay, how to calculate it? I have the selling price, which is 0.13 euros per kilowatt hour. I have the turbine number of kilowatt hours. Okay, so I just have to multiply the selling price, which is 0.13, by the number of kilowatt hour. Sometimes, instead of giving you directly the number of kilowatt hour, they can just give you the number of hours of operation, because you know that the power of your turbine is 3 kilowatt. So if I tell you what is the number of operation of your turbine, you can assess the energy produced. Okay, so for example, if I tell you it's operating here, it will be operating for 2,500 hours. So instead of giving you directly the total energy produced in kilowatt hour, which is equivalent to joule, it's energy unit, okay? I can just give you the number of hour of operation, and knowing the power of the turbine, you know that energy can be calculated as power times T, times time, okay? So since here you have the power and you have the time, then you can assess the value of the energy. Okay, here it's directly given, so you just multiply 0.13. You can see here that the unit of 0.13 is euros per kilowatt hour, so you should multiply by the number of kilowatt hour per year to obtain the income for each year. So here we should multiply by 7,500. Okay, and we will perform the same operation for the second year. So we multiply for the second year, the income will be 0.12 times 7,500. For the third year, it's 0.11 times 7,500. And finally, from year 4 to year 20, the cost will be, the income, sorry, will be 0.1 times 7,500. Okay, so let us see these details in the calculation here. So first we have, as we said, we calculated the initial capital cost. You have the yearly maintenance cost, 2% of I, it's 120 euros. Concerning the wind energy per year, it's given in kilowatt hour. So from here we can deduce the number of hours of operation. If they ask for it, you can just divide the energy by the power. You get that it's operating for 2,500 hours. Here in this problem, you don't need this, no need to calculate. Okay. Now, in order to assess the value of net present value for the lifetime of the equipment, as we said, we should determine what is the cost what is the income for each year. So for year 1, as we said, we multiply 0.13 by 7,500. The same for year 2, 3, and then from year 4 to year 20, RI will be constant. Okay, while the maintenance cost is not varying, it's the same over years. Now we are ready to calculate our summation. Okay, the summation that we should perform is sum from 1 to n of Ri minus Ci over 1 plus a to the power I. Okay, but look, in this formula, when you want to predict the summation from year 1 to year n of Ri minus Ci over 1 plus a to the power I, you should pay attention here that if you want to use the mathematical formula, what is the condition? The condition is that this term is constant so that I can take it outside of the summation. If it's not constant, I cannot use this formula. So how to go over this? To go over this, I will try to divide my summation. And I will exclude year 1, 2, 3. Okay? Because for year 1, I have R1 minus C1 over 1 plus A. Okay? For year 2, I will have different R2, so it's plus R2 minus C is constant, so I will just put it as C. No need to put a number because it's not changing. So it's R2 minus C over 1 plus A square. For year 3, I have plus R3 minus the cost over 1 plus A to the power 3. While for all remaining years, yani now from 4 to n, I can add plus summation from I equal 4 to year n of R4, because R will not change anymore, the income, minus C over 1 plus A to the power of. So now my challenge is to determine this term, this summation, okay? Now, since R4 minus C is constant, I can take it outside of the summation. And now, what I should predict is what is the summation from 4 to n of 1 over 1 plus A to the power of. So I can use a small trick, a mathematical trick, because the formula here is equal to this term if I start from 1. If I don't start from 1, I cannot use this formula. And here I'm starting from 4. So how can I go over this? I can replace this summation by doing summation from 1 to 20 and then subtracting the 3 first terms. Okay? Because if you want to do summation from 1 to n, you will have 3 additional terms, which are 1 over 1 plus a plus 1 over 1 plus a squared plus 1 over 1 plus a cubed. So if you want to get sum from just 4 to n, you can take first the whole summation and then subtract from it the 3 first terms. In this way, you can replace this term, which is summation from 1 to n, by the mathematical formula. Okay? And this will simplify the calculation for you. Is this clear? Any question until here? Okay. So now this is what we will do. We will replace this summation by its value, which is 1 plus a to the power n minus 1 over a times 1 plus a to the power n. And then if I replace in my summation, my summation in the NPV value, we will see it here. So now NPV at year n will be equal to, so this is the year. You have initially the investment. You have, this is the income from year 1, R1, minus the cost C, minus 120 over 1 plus A, plus for the second year I have R2, which is 900, minus the cost, which is 120, over 1 plus a squared, because we are at year 2. For year 3, it's R3, which is 825, minus 120, which is the cost, over 1 plus a cubed. And finally, for the from 4 to n, this is R4 minus C. I can take it outside into factor. And then I replace my summation from 1 to 20 by its expression. And I don't forget to subtract the 3 first terms. Yani minus 1 over 1 plus a, minus 1 over 1 plus a squared, and minus 1 plus a cubed. And as you can see here, you can group terms together. And here you have 975 minus 120. Okay, this will give you 855. Okay, but also over 1 plus a, but also you have another term over 1 plus a, which is this one. 750 minus 120 will give you 630. So if you take into factor the terms in common with 1 over 1 plus a, you will have 855 minus 630 over 1 plus a. So over 1 plus a, you just have at the end 225. You will do the same. You will take into common the factors of 1 plus a squared and 1 plus a cubed. So you will end up with the following result, that MPV at year 20 is minus 6,000 plus 225 over 1 plus a, plus 150 over 1 plus a squared, plus 75 over 1 plus a cubed, plus 630 times, this is the replacement of the summation from 1 to 20. It's 1 plus a to the power 20, which is n, minus 1 over a times 1 plus a to the power 20. And this is the salvage value. So don't forget the salvage value. You should add it at the end. It's equal to the salvage value over 1 plus a to the power 20. Please pay attention. The salvage value is only included at the end of lifetime. So if you are calculating the NPV at any other time, you don't include the salvage value. Okay? Now, once we write this equation, you can see that the only unknown is A. Okay? Hello. For me, what is important? Yes.
So also for the ROI, we include the salvage value?
Yes, of course. Because what is the definition of the ROI? The ROI is the value, yes, it is the value of A for which the net present value at year n, which is at the end of lifetime, is 0. And since you reached the end of life, then you should include the salvage value. Okay? So whenever they ask you for the ROI, you should include the salvage value because you have already reached the end of lifetime. Okay?
Okay, thank you.
Welcome. So now, what is important for me in the exam for you is to reach this. And I can give you a similar problem. I'll just tell you to write me this equation. I don't care for the solution because it will take a lot of your time. And some people know how to do it on calculators. And it's not, if you want, it's not fair among students to, because if you want to do it in without calculator, you need to do iterations. So you should assume. So for example, here, this is what you should do, let's say. You should assume, let us assume A equal to 10, for example. It will give me a negative value for NPV. This means what? This means that I should try now lower value of A until reaching, I want just to have NPV is equal to 0. Okay? If you have a very low confidence in future, then your NPV will be negative. This means that you cannot take A larger than 10 anymore. Because if you try now A larger than 10, so of course you will have a more negative NPV. Because in order to increase your net present value, you should reduce A. So in general, we start with 10 to see how to continue. If you get a positive net present value for A equal to 10, this means that your ROI is higher than 10. And then you can try to to يعني you should find what is NPV for larger a, okay, until getting a value close to 0. Now, since you got here a negative value for 10, this means that you should not use, if you want larger value of a, you should use smaller values, because your purpose now is to get a net present value that is positive. If you try a equal 5, you will get a positive net present value. So you did use that the ROI should be in between. Okay. Now, yani, the idea is that if you want to perform on your own the iterations, you should know how the logic of calculation. So you should say, if I get a net present value negative, then I should try lower values of a. If I get a positive net present value, I should try a larger values for a. Okay. So here, once you selected these two values, you can be sure that the ROI is in between, because for a equal 10, NPV is negative. For a equal 5, NPV is positive. And even you can see that for this value is closer to 0. So the ROI will be closer to 10 than to 5. So now you can start, for example, with 9. You can try 9. If you use 9, you find a net present value of 141. So you can be sure now that the ROI is between 9 and 10, because for 9 it's a positive value, for 10 it's a negative value. So if you do some trials, you will end up with the accurate value of the ROI. So here nearly your ROI is 10, is close to 10. This is an acceptable ROI, because this means that for a confidence future in future below, and if I have a discount rate lower than 9.345, then my NPV is 0. So your range of risk is high, and you can take risks, because I have, even if I have high confidence in even if I have low confidence in future. So if in general confidence in future, if you want, if a is larger than 5, this is a low confidence. If a is smaller than 5, it becomes a better confidence in future. So even with a low confidence in future, which is nearly 9.5, 9.345, then my net present value will just be positive. So if I take any value of a below 9.345, I will get a positive net present value, which is encouraging. It's an encouraging value, because the range I can play with is large, relatively large. So if a varies between 9 and between 0 and 9.345, then I can be sure that my net present value is positive. So for me, it's good. Okay. So we can say until here that it's an encouraging value. So any discount rate lower than 9.345 will give me a positive balance. Now, in case, for example, they asked you if you want to have a profit, let's say, if you want to have a CER that is equal to 0.3, what should be your discount rate? What should you do then? What is the equation to use? If I tell you which value of A, which discount rate will give me a CER of 0.3, or which discount rate will give me a profitable project, what is the equation you should write, you think?
We write NPV divided by the initial investment equals 0.3.
Very good. So you said, instead of calculating the value of A that will give you NPV equal to 0, then to have a profitable project, you say that I should have NPV at year N should be equal to 0.3 times the investment. And since the investment is 6,000 euros, so I multiply by 6,000. So I say that NPV at year end should be 1,800 euros. Okay. So if you look a little bit at your values, what will be different here just is here, instead of having 0, I should set it equal to 1,800. Okay. And then if you look at the values here, you can say that what the discount rate will be in which range, do you think? Look, A equal 5 gave you a value of NPV equal to 2,000 266.32 euros. You want to have a value of 1,800. So you think that you should try a smaller discount rate or a higher discount rate?
Yeah, between 5 and 10 and 9 it will be.
Very good, between 5 and 9. So now you can do some trials between 5 and 9. هلا it will be closer to 5 also لأنه 1,800 is relatively closer to 2,266 than to 141. So maybe you can try 6 now, okay? And then you continue your trial until reaching an NPV close to 1,800, okay? Clear? So let us continue with the other questions. Determine the discount rate for a discounted payback period of 10 years. So now the question is, what should be the value of A to get a discounted payback period of 10? What do we mean by discounted payback period? This means what is the time needed to just have a balance of 0, okay? So the equation to set in order to find the discount rate for which the payback period will be 10, this means that for year 10, at year 10, we will have 0 balance. So NPV 10 is equal to 0. Now, your equations will not change a lot. Yani once you do the first step, the other equations will be very simple. Just you should pay attention. Here, you should not include what? And you have the same equation, but instead of year end, you put to the power 10. And instead of power 20, you put to power 10. And you don't include the salvage value. Okay? So these are the two modifications you should do in your equation. It's exactly the same equation. This is the investment. This is R1 minus C1 over 1 plus A, etc. All are the same. Just here, when you want to assess the summation from 4 to 10, you do power 10, not power 20. Okay? And you don't include, so here it is 10, and here also it's power the year, which is 10. And no salvage value here, no salvage, okay, because we have not reached the final year. So now also same method to get A, okay, we do iterations. So here you can see what are for different A's, what will be your NPV. So for example, here we tried first 2%, we got a positive result. We tried 3%, we got a negative result. So A is in between. Then by performing some additional trials, we can find that nearly the discount rate to have a payback period of 10 is 2.315%. Okay, and this means that you know that for the payback period, smaller is the payback period, what will happen to A؟ يعني أنا كل ما صغر ال payback period شو بيصير بالديسكاونت rate, do you think؟ كل ما صغر ال payback period منطقيا
It becomes smaller because we have, يعني, the time we are predicting shorter.
Yes, إذا discounted payback period أصغر يعني أنا I am able to gain my money again in a shorter period of time. And I am more confident in future. So to have a smaller discounted payback period, you should have a smaller values of A. Okay? لأنه كل ما صغرت A, كل ما أنا more confident in future, كل ما I will gain more money, and then I will be able to balance my my costs in a smaller period of time. Okay? Now, another question. If we set the discount rate for 5%, determine what will be the corresponding discounted payback period. أول شيء sometimes إذا بيعطوني several questions بقدر استفيد من الquestions اللي قبل. يعني لما كانت ال discounted payback period 10 years قد ايه طلع ال value of A؟ طلعت 2.3. So what do you expect now بما إنه زدنا ال discount rate to 5? What will happen with the payback period?
It will increase.
Exactly, it will increase. فنحن now, what we will do, we will set in mind that it should be the payback period now will be higher than 10. So when we do trials, we don't start from low values, okay? So here, The same procedure will be adopted, but now what is unknown is n, and a is given. So when you want to replace in your equation, we will use the same equation of the previous question, just instead of a, we replace a by its value, يعني اللي هي هون 5%, and n will be the unknown now. Now the n will be the unknown, which is the number of years. Okay, so to get the payback period, we just have to solve this equation. The only unknown is n, which corresponds to the number of years required to have a balance of 0. So now, since we expect to have a period larger than 10, because already in the previous question, for a payback period of 10, the confidence was smaller than 5%. So we can start from 11, from 12. So if you start, for example, from 12 years, you will get an NPV that is very close to 0. Yani -1 is nearly 0, you can consider it. Okay, so you can say here that nearly the payback period will be 12 years. Okay, any question on this? So this was our problem. In case you will have any other questions after, you can text me whenever you want. Okay, so feel free when you study the videos, when you go over them, to ask me your questions if anything is not clear. Any question on this before we move to the presentation?
Doctor,
Yes.
in terms of solving, and
Yeah.
only in chapter 8 we have solving. Okay. Okay.
You have just also in chapter 7, but there are very simple problems. The problems are already posted, okay, with the video explanation. But you will see, and the most complex is chapter 8, and the other chapters are very simple. And even we have tackled them in the first chapters. And if you know in chapter 2 and 3, if you understood well the chapters 2 and 3, you will use them in calculation of chapter 7. So for solar energy, for example, you should know how to write that, for example, that the convective flux is transformed into, let's say, a sensible heat that will raise the temperature of water, and such things. The concepts are the same that we learned in chapter 2, just we can use them in solar problems. You have all videos on these problems in the playlist. And then in case you face any problem with them, you can ask. So mainly your problems will be on chapter 7 and on chapter 8. And these problems will not require just a common sense. It will not require a lot of study. You don't have to study chapter 2 and 3 again. The final will not cover all chapters. It will just cover the part after the midterm. But just you should understand the concept. You should know what is convection, what is sensible heat. Just you should know the concepts, but no need to go over the chapters again in detail. Okay.
Professor, I have a question concerning the timing of the final.
Yes.
Is it possible to make it a bit later, because 8:30 is a bit early?
Look, I don't mind if you all agree on one date. It's fine for me. Okay. But because you have each student has a schedule, and maybe I don't want to put pressure on. If you can find one agreement for all, it's fine. We can talk about it on the group. Please ask on the group if we can. We should find a time where no one has a final or no one has another final close to it. So this is the issue. But if you can agree on one date, it's fine for me.
Maybe same day afternoon, if everyone is okay.
Yes, if everyone is okay, it's fine. What is the date? They selected the date?
7, I think. 7 of May.
7 May?
Yes.
Okay. Okay, so Leila, we will discuss it on the group.
Will you post a previous exam also?
I will, if you want, I will try to prepare something, but it's the same style. Now you are familiar with the style. It's the same style of the midterm, okay? And same style of questions. Now you know the type. This is the type. I ask from from the course material multiple choice, and I give some small problems. Yani just if you practice with the problems I gave you, it is more than enough. You will be ready for the exam. Okay.
But doctor, this issue of not being able to return to the question is really stressful.
Look, I know this, but you know, in online exam, we are forced to do this. Believe me, with all of these strategies, I still have problems in cheating and to see if the student is doing the job on its own or not. So we should do these measures. Well, online will be like we are playing if we will not do this. Okay, but I am giving you partial grades for this to not be stressed. So and the questions I will give you يعني خلاص you or you know or you don't ما في إنه I should think 1 hour to know what is the response, because the problems I gave are typical and I'm not giving you something very challenging. So if you just study the material and do some practice, you will be ready for the exam. And I told you whatever you do I will do if I will put a partial grade. So if you don't know how to continue, you will get a partial grade. So you stop where you يعني you just do what you know and you should pass to the other question.
Yes, but the problem is always that you don't know what's coming next. Can we at least have, for example, the multiple choice questions at first and then the problems?
Look, really, we can. Yeah, I can do this because
To
when
manage
I do
our
the
time
test, I
better?
should. But what I will do, like last time, I will put for you the time. What is nearly the time you need for each question? This will help you. And if I tell you that this question needs 10 minutes, then you don't exceed the 10 minutes so that you will have time to go over all questions. So this is what I will do. I will give you the time nearly for each question so that you don't exceed a lot this time. Okay? Any other questions? Okay. So, Sahar, you are ready?
Yes, I'm ready.
Okay, I will open a new session to do your presentation, Sahar, okay?
Okay.